Welcome to part 3 video of module 5. In the last video we were discussing the various backup technologies, and the first was direct attached backup. So we saw in the figure that the client should straight away send the backup data to the backup device, and on the other hand, through the LAN there is only metadata sent, and as such the configuration frees the LAN from the backup traffic. So the next type is the LAN based backup. In that case, you have the different units of the architecture, all are being connected by the LAN. So we can see the client sends the backup data to the storage node to the backup device, and the metadata also travels through the LAN to the backup server. So all of these need to have a comparison. Okay, so please study the comparison. And the next one is the SAN based backup. Now here you can see the backup server and application server or the backup client connected by a LAN, and you have the storage node and backup device, separate units. So when the data has to be sent, it is sent through the FC SAN, okay, fiber channel SAN, and the metadata through the LAN. Okay, so you can just read through to understand more. Next is a KTU question, that is mixed backup topology. Here you can see, as I said earlier, it is a combination of LAN and FC SAN. Okay, so in some cases the backup client will send to the storage node to the backup device through the LAN, as you can see, through the LAN, storage node and the backup device. You can see the arrow. Okay, then in some cases the backup client will send the data to the storage node and to the backup device through the FC SAN. So it is a mixed topology, and you can see both sends the metadata through the LAN to the backup server. Okay, next it is in a NAS environment. How is the topology, backup topology in a NAS environment? Okay, in that there are 4 types, that is the server based backup, serverless backup, and the NDMP, that is network data management protocol, 2-way backup and a 3-way backup. So the first is server based backup. So here the difference is, so you have a NAS head. Okay, so the NAS head and the storage array are the extra units here. Okay, and please note what all should be written, like a backup client, and here the backup server and the storage node are mounted together. Okay, so in each figure you have to pay attention what is together with what. Okay, and so in an application server based backup, the NAS head retrieves data from the storage array, okay, over the network and transfers it to the backup client running on the application server. Okay, so NAS head gets it from the storage array and it sends it to the backup client, which sends it to the storage node, which sends it to the backup device. Okay, so that's how the backup data reaches the backup device, and metadata from the backup client, it goes up to the backup server, okay, through that LAN. Okay, this results in overloading the network with backup data. Okay, then serverless backup, here we find that the backup server, storage node and the backup client are on the same unit. Okay, the application server is a different entity. Okay, so again in this scenario the storage node is also a backup client, reads data from the NAS head, and that is getting it from the storage array itself, and writes it to the backup device without involving the application server. So the NAS head gets the information from the storage array, passes it not to the server, application server, it goes to the backup client and then to the backup device, okay, to the FC SAN. Okay, then next is, that is serverless. Okay, then next is a two-way backup NDMP, okay, network data management protocol. So it is again an industry standard TCP/IP based protocol, okay, for NAS, and data is backed up regardless of the operating system. Then it no longer is necessary to transport data to the application server, so it reduces load on the server and improves the backup speed. So please go through the explanation of each so that you can point out some advantages of each type. Then it optimizes backup and restore by providing the high speed connection. Okay, then you find here that if you see in the figure, you can see an application server and backup client and a backup server right here. And so the NAS head gets the data from the storage array, and then it sends it to the backup device through the FC SAN. Okay, you can see the backup data there, and NAS head sends the metadata to the backup server through the LAN. Okay, then three-way backup means there are two NAS heads over here. Okay, and you can find they are connected by a private LAN, and from one storage array through FC SAN, NAS head derives data, and it sends it to the backup device, okay, by means of the other NAS device. Both are through the FC SAN and touching a private LAN. Okay, and you have the NAS head sending the metadata back to the backup server through the LAN. Okay, see the connections, application server or backup client over here and the backup server down here. So it is a method to avoid the backup data traveling on the production LAN. Okay, there is a separate private backup established between all NAS heads. Okay, and the NAS head is connected to a backup device, you can see. Then the metadata as well as some control data of NDMP are transferred across the public LAN, as you can see here. Okay, so that's it. So what we discussed earlier were the topologies of backup. Okay, then next we come to the backup targets. So it is physical tape, disk or virtual tape. So physical tape was the first one, traditional one, low cost, and it has only sequential access and so on. Then you note there is a shoe shining effect or back hitching effect, that is a repeated back and forth motion of a tape drive, which it makes when there is an interruption in the backup data stream. So it goes right from the beginning, right to the beginning. Okay, it causes degradation of service as well as wear and tear to the tapes. Then backup to disk, so when they are traveling to the disk or storing to the disk, now they are actually better than the tapes and more available, okay, and better performance, and these are the advantages. Then if it is a virtual tape, so that means it is virtual, it is not physical. Okay, and the key benefit is that it does not require any additional modules or configuration or changes in the legacy backup software. Okay, then it is it performs online and random and faster backup recovery and so on. Please go through it. Then virtual tape library, a simple figure. Okay, you have a backup server or storage node and is connected through an FC SAN to the virtual tape library appliance. Okay, with an emulation engine that is emulating it with the physical disk, and then a storage LUNs, that's the logical unit numbers, okay, to which it is mapped. Then it is connected through the LAN to the backup clients. And the figure shows a virtual tape library. They use disks as backup media, and emulation software has a database with virtual tapes, and each tape will be assigned to a loon. That's why it's shown like this, emulation engine on top, and they are assigned to the loons. Then unlike physical tape, virtual tape library is not constrained by sequential access or shoe shining effect. Okay, when the operation is complete, the backup software issues a rewind command automatically, and the restore operation is instantaneous. Now there's a comparison between the tape disk and the virtual tape. Okay, so just go through it, and we conclude here. See you in the next video.